as I said, lesson 4.2, data structures again. So just a quick recap. So one fortnight ago, which is 2 weeks, we covered lists and twoth lists, the most common and important data structure in Python. They have many functions and they're ordered and mutable. And twoth lists are lists inside of lists, and they're useful for problems that require grids. And now we'll be going over two new data structures, which are dictionaries and sets. So a Python dictionary is unordered and mutable. So unordered, so like you can't access things using indexes, and mutable, you can like add and delete things. So they're made up of two main components. So the key is kind of like in a dictionary, the word, and the value is kind of like the definition in a dictionary associated with that word. So dictionary should be surrounded by curly brackets. Each keys are assigned a value with a colon, and each key value pair is separated with a comma, and they can be created in one line or separated like multi-line lists. So keys must be mutable and unique, because like in a dictionary, you can't have two of the same word. And the values can be anything though, including mutable and mutable objects and duplicates. So for example, some dictionary words are synonyms and they have very similar definitions. And you can print and access specific key values by calling the key, as you can see on the right.
Yeah, should we show that in the applets? Oh. Well, let me change. Yes. So let's use this dictionary right here that we have. So a bit of a spoiler. Please let me, there we go. Of course, if we want to access it, we do employee, and then the key, which in this case, let's get the age of the person. If we notice if we run it, nothing will print because we're just accessing the value. We're not doing anything. So we can print it like this. We have the print statement. 36. We can also assign it to a variable. So age equals employee. And then we can print that out. That makes sense. Right, let's go back to the slideshow. So again, you can define a dictionary one key value pair at a time. So if we look over here, we define an empty dictionary with just curly brackets, and we can add keys by just doing the dictionary name, putting the name in the or the key in the brackets, and assigning a value to it. We did that again here. And you can also replace a key's value by accessing it. So we've accessed age, that's already been defined, and we're redefining it to the value 49. Unlike lists, dictionaries are unordered, so you don't call a specific index like position 0 or 1, you just call the key. So again, if we, as we showed before, we can just do person and then age, and then we can access the age, which is 49. We can also make nested dictionaries, which are just dictionaries in dictionaries, but that's not too common. And here's an example down here where we have people, and then we have the key being the ID of the person, so 1, 2, and we have another dictionary holding the actual information. You can also check if a dictionary has a specified key with an if statement. So if key in dictionary, so key represents the key name, and dictionary is the dictionary's name. So in this example here, we have if species in dictionary, we want to print out the, should say species, not age, but yeah. And here's another example. If key in dictionary, we want to print out the name, which is sans undertail. There's also two ways to loop through a dictionary with a for loop. So method 1 is we loop through the keys. And if we look to the right, we just do for key in person. We can print out the key, and we can also call the person's key and print that out, print out the value. The second method is a little more complicated. you can loop through both the keys and the items using the .items method, which we'll talk about dictionary methods more on the next slide. So note that we have to, that the .items method will return a list of tuples, which we will not get into. So to extract the values and keys from the tuple, we have to make sure that there's two valid variable names separated a comma. So in this case, we use key and val, and they're separated by a comma in person.items, and then we can print the key and value just like that. And here's the output, and it works.
So as mentioned in the last slide, dictionaries also have methods, and they can be assigned to variables or called on their own line of code. For example, dictionary.clear. And to the left are some examples of like the general syntax of dictionary methods.
Should we switch over so we can show them? Have it copy pasted here. So if we run this, we'll see the output. I think we could do this one at a time. So I'll just use a oh, we don't print it out. That's my bad. So this first example, we're using the .keys and .values, and we extract a list object of the keys. If we want them to be specifically a list, we have to use this list function to convert them into a list. So make note of that, and we get a list of the keys, and we get the list of the values associated with those keys. Yeah, actually, you know what? Let's comment this out so we can go through each step. So this next one is removing a value by specifying the key. So using pop, we can remove data structure, a specified key. Now, pop is a little interesting because you actually don't need to call it in the print statement. You can just call it by itself without assigning it to a variable, and it will still work. So if we print out the dictionary, you'll notice that dictionary will be the same, but it won't have a data structure anymore. So essentially what pop does is that it mutates the dictionary. So it removes data structure and its associated value, and then it returns the data structure and its associated value. So we can assign this to a variable. So word, we print word. It should print out the value. And finally, for the last one, I can't write these comments. Dictionary.clear will clear the dictionary. These multi-line comments are really good. Dictionary is empty. Another thing is dictionary.clear mutates the dictionary. It clears all the values, but it doesn't have a return value. So you don't have to assign it to a variable. For example, if I assign it to a variable, you'll notice the return value is none. And if we remember from our functions lesson, none means no return value. It means nothing. So we can just use dictionary.clear like this. So over here, we have a list of dictionaries and all their methods. For the most part, the ones we just showed are the most useful. But if you would like to look at them, you can always look at them. Again, this only shows the name of the method and a basic description. So if you want to see the parameters for each method, you'll have to click on this link and go through them. So here we have a dictionary exercise. So just to check that everyone understands. So when you're given this dictionary employee, maybe you could type the answer into chat. You can access and print the employee's salary and remove the employee's age. Or .pop is a method you can use to remove a specified key. .remove is close, but in this case it's .pop. Again, as we said here, you can just call .pop. You don't have to assign it to a variable or do print because it mutates the dictionary and removes it. Of course, you can assign this to a variable. but you don't have to.
Why is remove incorrect?
If you look back at the list, there is no .remove method. So some data structures do have .remove, and it does something different, but in this case, dictionary does not, and it's .pop. Let's go back. Here's a bonus problem. We have a nested dictionary, so how can you access on print Mary's physics mark? And again, we have a hint. How do you access specific values in a nested 2D list? So can you guys think about 2 weeks ago? And can you do the same with dictionaries and their keys? So yeah, it's a little long. So again, we print school. So the first key we want to access is students. And then after that, we want to access Mary. And then we need to access marks and then physics. So again, every time we access the key, we get its value, and we want to access the key of that value. We keep on doing that until we get to physics. Yeah, so you were close, Stefan, but you're just missing a few keys in between. Very interesting problem. So next data structure, which I just mentioned before, is sets. So sets are unordered and unindexed, and they don't allow duplicate values, and they're mutable. So you can't change any values because they're unindexed. So again, if we look at the example on the right, we try to change at index 1, and it doesn't allow us. So they're quite useful when you want to use unique values or for math operations like unions, which we will not be talking about. And you can define them like lists, except with curly brackets instead of square brackets. And if you want to define an empty set, remember how empty dictionaries are curly brackets? You can't do that with set. You'll have to define an empty set with this. So set, open bracket, close brackets.
I have a question.
Yep.
What does mutable mean?
So we didn't really talk about mutable, but essentially mutable objects allow you to do this kind of operation where you can specify an index and change it. So you notice how lists, we can call a specific index and change it, but for things like sets, if we do this, it will error. I think that's a really basic explanation because it is a lot more complicated and we're not going to go into it too much.
Wait, so would it be not mutable, like sets?
Yeah, wait, actually, that's a good point. Why does it say... Oh, well, actually, because you can't access values. It's that you can't edit them like this, because you can't access them with methods and change the values. We'll have to go back to that slide later and check. I don't know why. Let's move on for now. Since sets are unordered and unindexed, you can't access items by their index. So you can loop through a set's elements just like you would in a list. So for value and set name, we can print the element and it prints out. And we can also check if a certain value is in the set by checking if value and set name. So we're checking if banana is in the set, and it is in the set. So yes, you can change values in the set, but because you can add and remove values, sets are mutable. So you can add a new value with the .add method. So in here we add grape and cherry. And you can also remove a value with a .remove value or method. So we remove apple and we print the set and apple's gone. If you're using .remove, you have to make sure the element exists in the set, otherwise it will error. So that's why we have this if statement here to check if apple is in the set. And you can also discard a value with the .discard value or method. And if the element does not exist in the set, it will do nothing, so no errors. I think we go into the difference in the next slide. You want to explain that, Eddie?
Yeah, so the difference between .remove and discard. So discard doesn't throw an error in this example right here, but remove does when you try to remove an element that doesn't exist. So why would you use .remove at all? Well, in some cases, you might want to catch errors for debugging purposes, but like for general use, you can use either one. So again, here are all the methods for sets, and they don't show parameters and only basic descriptions, and you have to click on them to get those. But you can't click on them right now since it's a presenting screen. So
how about I show them? I think I might have to quit out of this because I don't think anything's going to be spoiled, but you can just open up the website and you can look at this. Oh, I would click on the link, but the tab, but the zoom bar is in the way. Wait, can you click on it, Eddie? The tab I just opened? Thank you. And you can see you have examples here. You have the usage, syntax, and the parameters. So very useful, and you can try these out yourself. This would load. Yeah. Again, you can do this for any method.
okay, so we're at set exercise. I try to write a function that accepts a string as a parameter and uses a set to check if a given word has unique letters, and return true if yes, and otherwise return false. So some hints are that you can create an empty set using set with empty brackets. Try to remember which method lets you add elements to a set, and recall that you can loop through a string with for char in string.
Again, char is the letter, each letter in the string. And make sure the string you're looping through exists. So string would be, you would replace that with the string you want to loop through. Okay, so here's the sample solution. We have the function, we define it, unique words, and it takes one parameter, which is a string. And then we define the set, store the unique values, we loop through each letter, and if there's a duplicate, we return false, because that means all the letters in the word are not unique. Otherwise, we add it to the set, so we can check it if the letter exists or is a duplicate. And if we make it through this loop without ever hitting this false statement, then all the letters are unique, so we return true. So you can test this out in the interactive window, but right here we have some examples. So if we do unique letters happy, it should return false, and unique letters Python, it returns true. Again, we post a slide, so if you really want to test it, you can copy paste it and try these test cases. So we have this kind of summarizing little exercise practice problem. So which data structure should you use? So the first one, you want to have a data structure that holds the names of each JoJo's Bizarre Adventure part, along with the summaries corresponding to each one. The answer is indeed dictionary. So for our second one, you want to keep track of the ages of the people locked in your basement. They consented to be there. You'll have to change the values as they get older and remove some values as people disappear. Which one's the best data structure for this? In this case, it would be list, because we only want to keep track of the ages, so numbers, and because lists are very easy to change values and remove values, a list would be a best choice. And for the last one, you have an amazing idea to store the usernames for all the accounts of your web service in a data structure, but you don't want any of the usernames to be the same. So would a list, dictionary, or set be the best for this scenario? Set, because as we said before, sets, you can't have any duplicate values. So now we have a practice problem. Let's create an account login program. So we want to create a data structure that holds all the usernames and their corresponding passwords, and we want to ask the user for a username. If that username doesn't exist, we want to reject them through a print statement. And again, you can check if a dictionary key exists with if key in dictionary. Then you want to ask the user for a password, assuming they put in a valid username. And if the password doesn't match the username, tell the user they've inputted a wrong password. Otherwise, tell them they've logged in with a print statement. So for those who want to go the extra step with this login like accounts problem, you can give the option to sign up for new accounts. And then there's also a second part to this. A company with no morals has hired you to harvest data from registered users. While the user is logged in, you want to give them the option to log out or take a survey. And if they choose to take a survey, ask them a question and add their answer to a data structure. So this is the bonus.